Hello, this is Professor Biswas. Today we will talk about right triangle trigonometry. So I'll give you some basics. In previous videos I did use the unit circle approach, but in your trig book probably you also are shown to do the same kind of math using the right triangles. So I'll just go over them very quickly so that you're familiar with it. Alright, since we're talking about right triangles, so I drew a little right triangle for you. So we have this angle here, theta, and we are going to define what everything is in terms of sine, cosine, tangent, cosecant, secant, and cotangent. The first thing we are going to label these sides. The base is going to be x, and the height is going to be y, and the hypotenuse is going to be r. And here's our theta. So let's write everything out. Sine theta is going to be opposite over hypotenuse. Opposite side, that's going to be y over hypotenuse r. Unfortunately, you have to memorize some of these. Cosine theta, on the other hand, is going to be adjacent, right next to it, over hypotenuse, x over r. Alright? Now, tangent, you can think about it as sine over cosine, or you can just think about it opposite over adjacent. Opposite to the angle over adjacent. Now, with the same token, cosecant is 1 over sine. That means you're going to reverse this guy that you wrote, sine theta. So when you reverse it, you get this. Hypotenuse over opposite. Then secant theta, you're going to reverse the cosine. So that's going to be r over x. And cotangent is going to be reverse of the reciprocal of tangent, so that's going to be x over y. Alright, now that we have those equalities, you just need to memorize them. And also memorize the cofunctions. Remember when we were making the little table and you looked different angles and you found out that they were related. So for example, cosine of 30 degrees was the same as cosine of 60 degrees. You remember those? So we can write some cofunctions as such. Sine of theta is cosine of 90 degrees minus theta. Or you can do it, this is one couple, you can do it with the tangent. The tangent theta is cotangent 90 minus theta. It always is helpful to memorize those. And if you write it the other way, cosine of theta is sine of 90 minus theta. And the last one, secant of theta is cosecant of 90 minus theta. So you can do very simple problems by using it. Usually they are going to give you things like, a right triangle. You're going to have an A, B, and a C. And then they're going to give you some kind of angle. It doesn't matter what it is. And you can be asked to find C. One way to find C, if they are giving you A and B, then you can use the Pythagorean Theorem. But in this case, they are not giving you B. You have a question mark, and they are not giving you C. So what do you need to do? Maybe I can use some equality. For example, sine of 32.1 degree is equal opposite over hypotenuse. Since I know the opposite, I can calculate the hypotenuse. Look at this. I know 2 over c is sine of 32.1. So what I can go and write, c then is 2 over sine of 32.1. I can do that in my calculator, and let me show you. You can go to your calculator. And make sure that if you are doing everything in degree mode, make sure that you are set in degree mode. And you do that with going to degree in a TI-84. So I got that. And what was my situation? 2 over sine of 32.1. So I go 2 over sine of, and you're just entering 32.1. And you just come up with 3.76. And you can go and write that out. And it's more than A. That makes sense. If there are units associated with it, like meters, it's going to be meters. Let's say they are asking you what B is. What can you use for B? I know the A, and I don't know B. Well, maybe I'll use tangent. So you know that tangent of 32.1 is going to be opposite over adjacent, opposite over adjacent. And I know what the opposite one is, 2 over B. So I can write B as 2 over tangent of 32.1. And you can go to your handy dandy calculator again. 2. Let me put this like that so we can see it. 2 over tangent of 32.1. And since it's already set in the degree mode, I don't have to do anything. And that gives me, what was it? 3.19 meters. All right? Okay, let's put it up a little bit so you can see it. All right, so you do these problems using sine and cosine and just try to practice. You can do another one if you want. So let's do another one. In that case, I will give you maybe an example of, you know the sides, but you don't know the angle kind of thing. So I just draw a random triangle. Let's say they give you A of 5. They don't give you B, but they give you C, and they don't give you alpha. How do you do a problem like that? So for a problem like that, you can write, for example, sine of alpha, and that is going to be 5 over 7, right? Now, I can get the angle. How is that going to work? You take the sine inverse of both sides, and that's going to give you an acute angle. So take sine inverse of both sides. So that means alpha is going to be sine inverse of 5 over 7. Okay? So you can go to your calculator. Sine inverse actually is built in. So you can go and you pick that up. 5 over 7. And remember, I had set my calculator in the degree mode. So it's going to give me this thing approximately 45.6 degrees. All right. Now you can go and you can get the others. Let's go to a new page. I can get the others. Something like I can probably get B using the Pythagorean Theorem. You don't have to. A squared plus B squared equals C squared. Then C is going to be square root of A squared plus B squared. And let's plug that in. we are going to get A was 5. Oh, sorry, I just didn't know the C, so I have to go back to here because what I do not know is B. So let's write this down. B squared equals C squared minus A squared. You take square root of both sides, so B equals square root of C squared, which is 7, minus A squared, which is 5. And you write 49 minus 25, and you need to take the square root of that. So you can do that and use the square root button. And you have 7 squared minus 5 squared. And close the parentheses. And that's going to give you the B, 4.9. Okay? So you can actually solve these things. What else do you need? You have A, B, and C, and the angle. You're done. So you can use a combination of sine, cosine, Pythagorean theorem to solve any triangle if you are given a right triangle.